Okay, let's start with covalent bonding, or continue with it, I should say. Okay, and this is sharing electrons, and this is where we can draw those Lewis structures. Okay, and we make molecules as opposed to crystalline structures with ionic compounds. Okay. Obviously we form bonds, single, double, or triple bonds may be formed. Single bond has one pair of electrons, double has two pairs of electrons, and a triple has three pairs of electrons. This is the weakest and the longest is the single bond. The double bond is shorter and stronger, and the triple bond will be the shortest and the strongest. Okay. We may also have electrons that are not shared around an atom, and those are called lone pairs of electrons. These are not shared. There is also something called coordinate covalent, which is also sometimes referred to as dative. But that's actually, this term is going away in the next round, or the updated curriculum. Okay, but a coordinate covalent bond is one where both electrons are donated by one atom. An example would be in ammonia. Those two electrons. When I react that with a hydronium ion, which has no electrons, I will form the ammonium ion that has a plus charge. Okay, you do need to draw brackets and the sign for a polyatomic ion for a Lewis structure, or you would be incorrect. Sometimes a covalent coordinate bond is shown with an arrow indicating that that atom has donated both of those electrons to the bond. Okay. You would also show this in carbon monoxide, with oxygen giving one pair of electrons to form that triple bond. Also with the aluminum chloride dimer, got carried away. This is the aluminum. Okay, so to form the dimer, there's two chlorine atoms that form coordinate covalent bonds with the two aluminums. Okay, so in generally speaking, the shorter the bond length, the stronger the bond. And this would indicate the strength of the electrostatic attraction for those electrons to the nucleus. Okay, let's talk about resonance, and we'll talk about it a little bit more later. This is when we have a structure like the carbonate ion. Those are oxygens. I don't know what I'm drawing. Unshared pairs can also be shown like that. If I had more room, this would be next to the other. Double bond here, single, single. Now, that true structure of the carbonate ion is a blend of all these. and that's determined experimentally. So I don't really have a double bond and two single bonds. All of the carbon-oxygen bonds in carbonate have been experimentally determined to be the same length, and those are really 1 1/3 bond. So it has a bond order of 1 1/3. And we'll look a little bit more, if you remember the term sigma and pi bonds, we'll look at those later. All right, but the idea is resonance structures. It's the blending across the entire molecule of that double bond. Okay, how do we determine if a bond is ionic or covalent? You can look at the difference in electronegatividity. There's a table in your data booklet of electronegativities. If that difference is greater than 1.8, it is said to have much more ionic character than covalent. If we look at aluminum oxide, the change in electronegativity is about 2.0. If we look at aluminum chloride, the change in electronegativity is about 1.5. Aluminum oxide would then be said to be ionic, where aluminum chloride is said to be covalent. Okay. Most often in general terms, because I just showed you an exception, if you have a metal and a non-metal, it would be ionic. As you remember, hopefully you do have to know some specifics about both aluminum oxide and aluminum chloride. All right. Okay, most often compounds will have some ionic character and some covalent character. So, if a compound conducts electricity, in its molten or aqueous phase, it would be considered ionic. That's supposed to be an arrow. That's not much better. Okay? Alright, let's talk about polarity of bonds. Okay. And this is really if I have unequal sharing of the bonded pair of electrons, I will have a polar bond. So you're looking for any difference in the electronegativity. So it's really two different atoms in the bond. You create a dipole moment. So for like HCl, chlorine has a higher electronegativity, so it is going to have a partial negative charge. Hydrogen is going to have a partial positive. It's this difference is the dipole moment. Okay. I will have a non-polar bond if there is equal sharing of that bonded pair of electrons, and this is between two same atoms.